Hi, so today we're going to explain problem 7.60, and the problem presents you four different orbitals next to this 3s orbital, and the idea is that the size of the 3s orbital is relative to these other orbitals, or that you can measure the size of these other orbitals relative to the size of the 3s orbital. In the first orbital that they show you, orbital A is clearly a p orbital because it has that dumbbell-looking shape, and it's about the same size as the 3s orbital. The next orbital, orbital B, is about the same size as orbital A, but it's a d orbital, and the reason is because it's kind of two dumbbells cross each other. So that's clearly not a p orbital, but a d orbital. And then, like I said, based on how tall the orbital B is, you can see that's about the same size as orbital A. And that's more clear in the textbook. Orbital C is clearly smaller than orbital A or B, and it's also a p orbital because it's dumbbell shaped. And finally, orbital D is a dz squared orbital. So it's actually also a d orbital. And even though it has this weird dumbbell shape at the donut hole, it's not a p orbital. So the five d orbitals look kind of like this. Let me see. And there's one more. It's more like. So if you had an xy axis, it would be more clear. But basically, there's five different d orbitals, and one of them looks kind of strange like this. So anyways, getting on to the question. The first question asks, which orbital has the highest value of n? And because we only have their relative sizes to use, we have to compare them and see which one's the largest. And the reason is because n is a size of is a measure of how large the orbital is, how much it encompasses the area around the nucleus, and how energetic the orbital is. So clearly the largest orbital here is orbital D. So, and the answer is D as the largest orbital. The second question is, which orbital has a value of L equals 1 and L equals 2? So if you recall, L is like a code for the type of orbital that you have. So for L equals 0, that refers to an s orbital. L equals 1 refers to a p orbital. L equals 2 refers to a d orbital, and so on. So for L equals 1, that is referring to a p orbital. So the only p orbitals we have are A and C. And then for L equals 2, that refers to a d orbital, as L equals 2, as 2 stands for d. And in this case, B and D are the only two d orbitals. Next question is, how many other orbitals with the same value of n have the same shape as orbital B and orbital C? So for orbital B and C. So you need to look at what orbital B is, and orbital B is a d orbital. So how many other d orbitals are there? Well, the rule is that the next quantum number kind of tells that m sub L. And m sub L is equal to negative L to positive L. In this case, because L is 2, since this is a d orbital and d refers to L equals 2, that means that there's negative 2, negative 1, 0, 1, 2. So there's 5 different d orbitals, as I showed originally. And because this is one of them, they're asking how many others there are of the same energy level. Clearly, orbital D is of a larger energy level, so it's not of the same energy level as B. And that's because D is much larger than B. So that means that there's 4 others that aren't on this board that are the same energy level and are also a d orbital. For C, we're referring to this p orbital. And the p orbital in this case is smaller than these others, so it is in its own energy level. P refers to L equals 1, so M sub L equals -1, 0, and 1. So there's 3 different orbitals, which means that there's 2 others besides this orbital C. And the last question is, which orbital has the highest and lowest energy? So the highest energy and the lowest energy. And as you recall, in this problem, with what we have to measure energy based on the size of the orbital and use n to determine that. So the one that has the highest energy is going to be the largest, and that would be orbital D. And the one with the lowest energy would be the smallest orbital, and that is orbital C. And that's the end of this problem.